Hi there, Internet. Today I want to show you a new toy I acquired. It's one of these ultrasonic sensors. Hold up. Yeah, the Arduino manual, you can see. One of these. And what it really is a rangefinder of some sort. It sends out a signal and you can pick up a signal with it. Basically, you can do it with 2 speakers. And funny enough, I did it with 2 speakers. And it works the same way. However, this is set up on a nice board. And not sure if you can hear it. No. But it's actually hooked up to one of my Arduino Uno replicas. That's only because my real Arduino is in use right now. So once this is hooked up, it really hooks directly into the Arduino, as you can see, to power, ground, and 2 random digital pins. And the reason I used these over here is because it was those that was recommended in the tutorial, but you can really use any. There was a manual with this, a PDF file, and it had an example calculation how to calculate this, and that's the one I followed. So let me show you how it looks. Here we go. This is the program, and let's open the serial monitor. Wrong COM port. Yes, sorry. There we go. Now you can hear. Just holding it up to the mic. And you can hear the small ticks. That's the same sound a bat make when they're flying around. And there you can see it's posting a range in centimeters. And let's turn off auto scroll. A range and a ping time. And the ping time is just something I like to see how long it took. And that's not the real time, because that time right there is the one from the piezo. That's actually a piezo crystal in here, out to something where it reflects and back. Now the thing is, you can point this in one direction and you would expect it to just ping off directly in front. But if you look inside this, I can't show it on camera, but if you imagine a parabolic disc, just like a satellite receiver, it's shaped like this. And this shape is actually causing reflections from a wider angle than just straight in front. So if we enable auto scroll, I know for a fact there's at least 2 meters over to the thing it's pointing at right now. It's a monitor on a Linux server that's standing over there, and it's only showing 56 centimeters. Now it's showing, that's just me tilting it very slightly. And if I tilt upwards, then we're pointing upwards to the ceiling. There we go. That's one of the 2 meters. That's more realistic. However, that's because we are clearing this disk area down here. And if you can see it now, you can also see my hand. There we go. We got a few 40s. And that's because my hand is in range even though I'm pointing far up. So if I'm going like this, it's level now, and my hand is roughly 30 degrees below the angle. So that's something to consider when using sonic rangefinders like this. But it's very, very cool. Did it? Yeah. Calm down. Short circuits when you touch it. Let's go over the program. You define 2 pins, just the pins you use, and you can use any form of, you can just define them as integers as well, that would work. You set the pin mode, you define 2 long variables, time and range. Those are the 2 variables we're going to detect. Well, we're only going to detect time. That's all. Then we're going to set the trigger pin. If you look at this, it has some text in it. You can't see it on camera, but there are 4 pinouts. The first one is voltage, the second one is trigger, the next one is the echo, that's the receiver, and the last one is ground. So we set the trigger to low, meaning it's not going to send out anything. Then we send out a signal and we wait. You can see it says 10 milliseconds. That's important to use milliseconds because normally we use, microseconds. Normally we use milliseconds, but we are measuring time in meters per second. That's standard SI units. And if you suddenly switch to milliseconds, it won't be a SI unit anymore. Okay. Set it to high, meaning we're sending out a ping. It's just going to say once. Then it's going to wait, and we're going to turn it off. This function called pulse in is actually going to detect how much time passed from the ping was sent until it was received again. That's all it's doing. How long on the echo ping before it went high? That's actually what we're asking, and Arduino would answer this. Then we divide the time by 2 because we are sending time out and time back, and we only need 1. And we divide by the speed on which sound travels in air, and that's 29.1. Oh, new mails, very nice. And then we just print it. How simple is that? Well, you can use that for some pretty strange things, but you can also use it for some fun things. Let's get rid of this. And I made a fun thing. You could actually do this twice with a very short range, and you can detect some speed of something. So you could make a sound radar gun, and that would actually be just like a sonar on a submarine. You ping it once and you ping it twice, and then you know how long, or you know the distance between those 2 points, and you know how long it took to ping them. Then you can measure his speed. You can do that with cars. However, in my previous tutorial some time ago, I told you about those small OLED screens. I got one right here. Well, not this one. This is from an old watch, but this one. These are awesome. And a original Arduino. Very nice, yes. And the real mega processor. Oh, very nice. Have to take care of this one. And you can see I got the wires hooked up out back, and I got a battery source. It's not hooked on, but I'm going to put this 9-volt battery on it any second. Power out, pin out, and on the breadboard I have a OLED display, and I have my little sonar. There we go. So let's just hook up the battery. There we go. And it powers on. I don't think the camera is able to pick up what's on the screen, but it says Rangefinder 1.0. That's mine. And it's actually displaying the range live from this sensor. So again, I'm pointing over to that monitor, and I'm getting around 1 meter and 56 1.60 meters, and if I point up to the ceiling, just like before, I get roughly 1.97 and 2 meters. So that means I got a transportable rangefinder now. That's pretty cool. You can, of course, build everything onto a gun and just insert a button, so you could have a trigger button, so it would only find the range when you press the button. That's pretty cool. At least I think so. So the code is actually just the same. The only difference is this time I'm including the Adafruit GFX libraries for SSD 1306, and they work fine with these OLED screens as well. And I got a menu, and except the entire thing from the program before, I compressed into this long find range, and you can see I just made it into a function. And inside the actual display, I just call this function to display the range. And you can see I got a delay of 500 and down here 500. So once per second, I'm getting a new range. That is very cool, I think. And that's about it, I have to say. If you're wondering what I'm going to use these for, I'm going to use them for my garden project, and I'm actually going to measure water levels. Traditionally, you would insert a piece of wire in a barrel at different ranges and just measure the resistance throughout the water. That's a bit old-fashioned. Well, so is this, but I kind of like this. And the reason for this is I'm actually focusing a lot about power consumption, and this right now, this Arduino hooked up with this thing and it's running, it's using 0.04 amps. That's very, very little. 0.2 watts. Yeah, I got this USB cable hooked up to a display, a measure. So I know always how much power my Arduino is running. Well, why don't we hook it up to this one with the OLED screen as well and check that out? And it's at 0.06 amps and 3.3 watts. So just waiting for it to start up. There we go. OLED screen running. It's measuring. And power consumption is 0.36 watts at 0.06 amps. So that's a huge difference actually, because this is the real Arduino from Arduino, while this Chinese replica is using most likely twice as much power. Something to consider. That's all, guys. Thanks for watching. Comment, rate, subscribe, and I'll see you next time. Bye.